Corporate finance practice problem using Excel. Impact of inflation on borrowing. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side, we're going to populate that into the blue area on the right-hand side, focusing in on the impact of inflation and borrowing. Scenario being, we borrowed in the past, we're going to say 15 years ago, 100,000, and there's compounded inflation rate, a yearly rate that we're going to say is 5%. So we're estimating that the inflation has been going up on average 5% over the time period of the borrowing, 15 years. We're going to think about then the effective purchasing power, or the impact on the effective purchasing power. And we'll imagine the situation if we had to pay back the loan with the same value, the same purchasing power of dollars, how many dollars then would we have to be paying off at the end of the time period? Now, this is important to kind of consider when you're thinking about what the impact of inflation will be on borrowing. Notice when we're talking about inflation, we're not talking about, as we did with the capital projects, thinking about the idea of having our gain that would be involved when we're doing our calculations for whether we would accept, say, a capital project or not. Here we're talking about just inflation, which is simply the purchasing power of the dollar going down. In the US, it could be anywhere from like 0 to 5% usually, but it could go above that as well. There could be times and periods of times when inflation is higher. And obviously, when there's instability about inflation, then there's going to be less questions, or the loaning, the ability to do any kind of business transactions, including financing, can be more difficult. Obviously, on the financing side of things, you could set things up with regards to loans and whatnot in many different ways. You might have a fixed rate on the loan, or you might have the loan could vary depending on basically how the loan is structured as well. Important thing to note is the impact of inflation on the loans and the borrowing, and of course, looking at periods where the inflation might be more volatile, what that might do to borrowing and whatnot, to other times when inflation might be more stable, possibly lower. So one way to get at this might be to think about what the cumulative inflation would be after the 15 years. So we could do this a couple different ways. One way which I think is a little bit more intuitive of a way, is we might just say, okay, let's imagine we have a situation where we're starting at period 0 of 1,000, and imagine that we have then the 5% of inflation per year. So I'm going to say from period 0, 1, 2, and so on. Going to select those 3 items, autofill it on down, grabbing the autofill handle, dragging that down, taking that down to the 19. Actually, we only want 15, so I'll delete the last few here. I'm going to center that, so I'm going to select these cells and center it, go into the alignment group and centering it. And then I'm just gonna say each time we just arbitrarily picked 1,000 here, so that 1,000 is just gonna be our baseline. Then we're gonna say this equals the 1,000 times the 5% increase each year, each period being a year. I would like that 5% to stay the same and this cell to move down. Therefore, and note this is often the case when you're looking at a cell that's outside of your data group, I'm going to make this cell absolute by selecting F4 on the keyboard, $sign before the B and the 5. You only need a mixed reference, but an absolute reference will work, so that's what we will use. And then we're going to say the change then is going to be the 1,000 plus the $50. We're at the 1,050. I'm going to just copy that formula all the way down. I'm going to select these 2, put our cursor on the autofill handle, drag that all the way down, and that'll get us to about the 2,079. Let's add some decimals just to give us a little bit more detail on this whole column. I'll just select this whole column, go to the number group, add a couple more decimals there, so we get some pennies involved here. So that, if we compare that, so that's basically where we would be. And you could think about that as kind of the equivalent future value, right? So if you're thinking in this scenario, you're thinking at after 15 years, that 2,078.93 has the same purchasing power in essence as the 1,000 15 years ago, due to the fact that there's 5% inflation that's being compounded. So we're going to go on down and say, okay, well, what if I compare that then to the original value, which was $1,000, the original 1,000. and take the difference. I'm going to go with underline, font group, and underline. That's going to give us the difference, which is going to be the 207,893 minus the 1,000. There's our change, our difference of the 1,078.93. And then if I take that original amount of, once again, the 1,000 to get the so we're looking for the cumulative inflation rate, which is basically going to be the percentage change. So the percentage change is going to be the difference divided by the original amount, the percentage change over the entire time period, that being the 15 years. So we're going to take then the difference, 1,078.93 divided by the 1,000, and then we'll make that a percent. Number group, let's make that a percent. So percent 108, we could add a couple decimals, 107.87. So that's going to be basically the percentage change that we're looking at over the entire 15-year time period. Now, you could also think about that. You might say, isn't there an easier way to do that? We could do a future value type of calculation. So you might say, why don't I use a future value formula to do a similar kind of analysis and say, well, the future value formula would then be negative future value, shift 9. The rate is going to be that 5%, comma, and then, so we got the rate, and then comma, the number of periods is going to be 15 years, 15 years on the periods, and then comma, we're not talking about an annuity, so we don't have a payment, so comma, comma, and the present value then is going to be that 1,000. That's that arbitrary 1,000 we put in there to practice our calculations for this analysis. Now note, this is a similar calculation that you might see for investment type of activity, where you're trying to see where will I be at the future point if I have this rate of growth type of calculation. But realize here that this 5% doesn't represent really the rate of growth. It represents inflation, the decline in the dollar. So we're talking about here how many dollars would we need to have at the end of this time period in order to have the equivalent purchasing power to us having the $1,000 at time period 0. So then we're going to say, okay, let's add a couple decimals there. So that gets us to, once again, that 207,893. And then you could do your same kind of calculation we did up top. The difference then is going to be, or if I compare that to the original amount, the original investment, which was the 1,000, we have a change over that 15-year time period. I'll add a couple decimals here to make it even. Font and underline. We have the difference or the change, which is going to be equal to the 207,893 minus the 1,000, adding a couple decimals there, number group, couple decimals, comparing that then to the original amount, and this is going to give us the percentage change, right? The original amount is the 1,000, and then we're going to say numbers, couple decimals, and that'll give us the percentage change or the cumulative inflation rate, meaning the percentage change over the entire 15-year time period, that being the difference divided by the 1,000, adding a percent here, number group, percentifying it, adding a couple decimals back to that 107.89. So once we have that, we could then say, okay, well, let's take a look at our effective purchasing power, or the impact of the effective purchasing power. If I had an original loan amount here, which was let's just call it loan amount. Loan amount was 100,000. Then I'm going to be picking up 1 plus the cumulative inflation, so which we calculated to be the change, or the 107.89. So it's going to say this is going to be equal to 1 plus the 107.89 change, making that a percent, numbers group percent. I'm going to add a couple decimals, so that gives us the 207.89. So then if we divide this out, or we're going to say this is going to be equal to the 100,000 divided by the 107.89%, add a couple decimals, and we're going to call that the effective purchasing power impact, and underline it, home tab, font group, and underline it. We have then the 48,101.71. So in other words, the 100,000 at this point in time only has the purchasing power of the equivalent purchasing power of the 48,101.71. You can kind of prove that to yourself by plugging it back into a calculation such as this. So if we did, for example, this same calculation here, let's go ahead and copy this and put this on the right-hand side. going to put this over here and paste this over here. We'll just do this calculation again. It'll already be there for you. And then let's imagine that we start off with, then instead of this 1,000, we start off with the 48,101.71, and then calculate our inflation, which is going to be that number times the inflation rate that we got over here. So that's picking up the proper numbers. That looks good. And then if I pull this all the way down to the bottom, we get to the end result of the 100,000, right? So I'm meaning if I had the starting point of the 48,101.71, I would need an equivalent amount of 100,000 after the end of the 15 years for the equivalent purchasing power. You can, of course, do that with our formula that we did down here as well, and do a similar kind of calculation with regards to the formula calculation, which would be negative future value, shift 9, the rate being equivalent to that 5% rate. And then we'll say comma, number of periods, we'll say 15, comma, because it's not an annuity, but present value of 1. And then if I pick up that 48,101.71, we'll get to, once again, that 100,000, which I should have put over here. I'll drag that over here and then format this cell back like that so it's nice and looks nice and neat. So there we have that. Now you might then ask, well, what, if the loan is paid in equivalent purchasing power, meaning basically when I pay it back, I have to take into consideration inflation. How much would I have to pay back? Meaning I borrowed the 100,000 and now it's like a flexible rate loan, and I have to pay it back in equivalent purchasing power dollars. Well, how much would I have to pay back in that situation? Well, in that case, we would take the original loan. We could say, all right, well, the original loan was the 100,000, and then we're going to be picking up our 1 plus the cumulative inflation again, which is going to be equal to the 207.89. Let's make that a percent, numbers group, percentify it, add a couple decimals, font group, and underline, and give our total here. Total, I'll just call it total this time. And then we'll take the 100,000 times the 207.89, add a couple decimals there. So we're going to then go numbers, add a couple decimals. So we'd have to be paying back then the 207.892 in order to get back to the equivalent units. And of course, you can kind of see that in our calculation here, where we started with the 1,000, and we would have to then get to the end point, the equivalent units in dollars after 15 years of the 207.893 about. So in other words, you could do that calculation and kind of prove it to yourself here with the future value calculation once again. Let's do that again. Let's call this the future value formula, and say this is going to be future value shift 9. The rate is going to be that 5%, comma, number of periods we're going to say is 15, and then comma, because it's not an annuity, but future value of 1. And then we're going to say we started with that 100,000. So where do we have to end at? We got to be at that 207.893. Not because we had any kind of gain or nothing happened here, except for the purchasing power of the dollar is going down. We're talking inflation. So we'll add some decimals. Let's make that blue as well. Let's make it blue. And so there we have that.